everyone. In this video, we'll be solving this problem. So there's an 8-person tournament. The odds of winning are 50% for each player, and we're asked to give the probability of 2 players meeting at some point in the tournament if matchings are randomly selected. And so have a think about it, and I'll be right back with the answer. Alright, so here's our bracket, and you'll notice that we have these 8 teams in the beginning, and then they match up and they win. If they win, they get to the semifinals and then the finals. And so we're asked to give the probability that if we pick 2 teams or 2 players at random, that they meet in somewhere in the tournament. So let's define players A and B. And yeah, we're just asked to give the probability that they meet somewhere in the tournament. And now there's a couple of different ways to solve this problem. I'll present the most intuitive way, and then I'll present a much easier way. But I think it's important that we do this way first. So what we can do is we can try to split up this scenario into 3 cases. And so the first case is where they meet somewhere in the first round. The second scenario is where they meet in one of the 2 semifinals. And the third case is where they meet in the final. Okay, and so let's start with the first problem here. The case where they meet in the first round. So you can notice that if we pick A and we put it anywhere, we put A anywhere in these 4 boxes. The only chance for them to meet in the first round is, for example, if we put A here, we have to put B here. And since we already picked A to be here, B has a probability of 1/7 of being exactly in the same box, since there's 7 spots left and only 1 spot fits the requirement. So for the first round, the probability is actually just 1/7. Okay, so let's move on to the second round. For the second round, you can notice that A and B have to be in the same kind of half of this bracket, but they can't meet up in the first round. And for example, if A is here, B has to be one of these two groups, and A and B both have to win their first games. And so let's calculate that probability. So for the second round, well, wherever we put A, if we put A here, B has two spots. If we put A here, B has 2 spots here, and the same if we put A here, B has 2 spots. So the probability is actually 2/7, since there's 7 spots left after we pick A, and and then B has two spots left. So it's 2/7. But remember, A and B both need to win their first games. So since they both have the probability of 1/2 of winning their games, it's actually times 1/2 times 1/2. And so if we evaluate this is actually just 1/14. There we go. Okay, and so let's think about when they meet in the final. Well, if we put A here, then B has to be in the other half, and B can actually be anywhere in this other half, as long as B wins both of his games, and A wins both of his games. They will end up in the final. So for the third round, if we put A here, B actually has 4 spots to go, so it'd be 4/7. Now, all we have to know is that A wins all their games and B wins all his games. And so this is just times, well, the probability that B wins the first game is 1/2. Probability that B wins the second game is also 1/2. So this is times 1/4. And same for A. It's just times 1/4. And so this is 1/28. Alright, so I'm kind of running out of space here, but the final answer is just going to be the sum of all these 3 probabilities. So it's going to be 1/7 plus 1/14 plus 1/28. There we go. And so we can, this is just 4/28 plus 2/28 plus 1/28, which is 7/28. So this is equal to 7/28, which is just 1/4. So the probability that A and B will meet at some point in the tournament is 1/4. Okay, so for completeness sake, I should probably tell you about the much easier, much faster way to do this problem. You can notice that in total there's 7 matches, since there's 4 first round games, 2 semifinals, and then 1 final. So in total there's 7 matches. And if you think about it, just by symmetry, kind of the whole situation, any 2 teams are equally likely to meet in any of those 7 matches. Since they're all just picked random from the initial 8 teams, and they all have the same probability of winning. So the probability that any of those teams meet at any of those 7 matches is equal. And so we just have to think about how many different ways there are to to pick 2 teams from 8 teams for each of these 7 matches. So this would actually just be A choose 2, which is 7 divided by 8 factorial divided by 2 factorial times 6 factorial. If you evaluate this, well, we can cancel. I mean, this is just 7 over like 8 times 7 times 6 all the way up to 1 over 2 factorial times 6 times 5 times 4 times all the way to 1. And so we can like cross all these out here. And so this is just going to be 7 over 8 times 7 over 2. We can cancel these out, and then this is just going to be 2 over 8, which is 1 over 4. So it's a much simpler way to arrive at this answer without doing the whole splitting up by cases thing that we did. But to me, at least, this is a little less intuitive, since, you know, it's a lot less visual kind of than the other way we did it. But, you know, if this makes sense to you, then that's good for you. Anyway, I hope you enjoy this problem, and I'll hope to see you here next time.